This is 6.2, areas under the standard normal curve. So we'll start with some basic properties of the standard normal curve. Our goal today is to apply properties of the normal curve to make predictions about quantitative data. So here's the properties. Property 1, will you read that one for us, please? Alia?
An important aspect of the distribution of a variable is its shape, and that we can frequently identify the shape of the distribution with a smooth curve called
Normal distribution, or normal curve. So we went ahead and jumped out of the definition. That's fine. Will you read property 1 for us, please, Toby? Well done. That's review. We know this. The area under the standard normal curve is always 1. So property 2 then, can you read that one for us, please, Dylan?
Standard normal curve extends indefinitely in both directions, whenever the horizontal axis.
Excellent. So we have horizontal axis, we have the curve, and notice there is space between the curve and the horizontal axis. Keeps going on, gets closer and closer forever. We call that an asymptote, if you remember from Algebra 2. Property 3, Mendez.
The standard normal curve is symmetric about 0.
Excellent. If it's symmetric about 0, we put the dots, connect the dots here. Area under the whole thing is 1. What would be the area to the left of 0? All of the area is 1. Split in half, it's 0.5. And so the area to either side of 0 would be 0.5. So property 4 then, Grayson?
Almost all the area under the standard normal curve lies between
Blank and blank, -3 and 3. That's our 3 standard deviations rule when we think about our standard normal curve. -3 and 3 contain almost all of our data. We'll jump to our steps here to determine a percentage or probability for a normally distributed variable. Will you read for us, please, Toby? Steps 1 through 4.
Step 1. Sketch the normal curve associated with the variable. Shade the region of interest and mark its delimiting x values. Find the z-scores for the delimiting x values found in step 2. Use table 2 to find the area under the standard normal curve delimited by the z-scores found in step 3.
Great, thank you. That's a lot. Those are 4 steps for the process that we're about to do. So I think it makes more sense when we put it into practice. But generally speaking, step 1 is to sketch the curve. Step 2 is find the region that it's talking about. When you have to do that in order to sketch it. And then you may need to use the z-score formula from yesterday. Who remembers what that is?
X minus that number divided by another number.
X minus mu divided by sigma, good. So that would be step 3, and then step 4 says use table 2. We haven't used that yet. I gave you 2 paper copies, just 2 versions of the same thing. It's referenced as table 2 according to this text. So you have z-scores to the tenths, and then to their hundredths value, and then the areas represented to the left of those values. So we have positive numbers on one side, and you'll notice if you look down the z column here, all the negative numbers on the other side. You'll notice this shaded region and this arbitrary delimiting value z is to the left of 0. Makes sense? Versus this z-score, wherever it is, it can be anywhere over here, but it's got to be to the right of 0 in order to be positive. So this is the same thing as the blue sheet. You'll just notice the blue sheet has smaller numbers, but it is nice because they've got the rows that really were highlighted, so that might help you keep track. for today's purposes, I'm gonna stick with the goldenrod color. Feel free, after our notes today to use either one. So let's take a look at an example. I am gonna skip this one example. Excuse me. But not this point. Can you read for us this point, please, Jade? Underneath the purple properties, or,
The total area
steps.
under the standard normal curve is like the standard normal curve is symmetrical halfway. So the area to the right of 0 is 1/2 to 1.
Okay, what goes in those blanks?
One and 0.
1, 0, and half of 1 is? Yep, 0.5. So this is just a summary statement of what we just talked about above in the properties. Next up, here we go. We're going to put it into practice in example 2. Determine the area under the standard normal curve that lies to the left of z equals 1.23. You'll notice the heading here, it says find areas to the left of a specified z-score. There's 3 categories that we're going to go through in order to find area. One is to the left of the given z-score, one is to the right, and then the other one is between 2 given z-scores. So starting off to the left of a given z-score, given it's 1.23, I'll go and find the z-score to the nearest tenth, 1.2. Sometimes I use another piece of paper to kind of mark that off. And then I find at the hundredths spot the 3 in this horizontal row here. 1.23 is going to land at 0.8907. So that would be the area to the left of 1.23. So this area here is going to be 0.8907. Example 3 is going to have us find that a few more times just for practice. So A says if the z-score is 1.41, what's the area to the left?
0.659.
You already found it? You're so fast. So if z equals 1.41, 0.9207, is that what you said?
That's a 659.
So I went to 1.4 on this z column here, and then I went over to the 1.41, so it's 0.92. Oh, okay. So you found it though? Okay, 0.9207. And then B says negative 0.56, so I have to go to the back side. Negative 0.56. So that, where does that one land? What's the area to the left of that one? Yes, 0.2877. I like to use a pencil when doing this because sometimes I do mark on my table. But if I use a pen, I get all these markings and it starts to look really sloppy, so I go back and erase. So 0.2877. I'm going to go ahead and let you try out C and D on your own. Make sure you can find those areas on this table.
Wait, how did you get, like, you know how you found 0.5 on the right? And then what did you look for when finding the top one?
So the value for B is negative 0.56.
Right, I found negative 0.6.
Okay, then on the top you have to find the 6.
Oh, okay.
Do you see that?
0.6, okay. And then go down. And then that was 0.2877.
Yeah,
Okay.
good. Raise your hand if you got 0.8554 for C. Okay, so if I look at positive 1.06, I gotta go to the 1.0, and then across the top, I'm looking for the 6. And I connect those at 0.8554. Raise your hand if you got 0.3483 for D. Okay. Good, hopefully we're getting the hang of this. Any questions so far? Do you have a question?
I still kind of don't understand it.
So if I find for D, it's negative 0.39, so I'm going to go to the negative side. And then to the nearest tenth, I've got 0.3, and then I'm looking for the 9 across the top, which is all the way to the left in this table. So I just have to line those two up. So the negative 0.3 and the 9 is going to line up here at 0.3483. Once you get some practice with it, it starts to become easier. Example 4 is in this next category of finding the area to the right of a specified z-score. Just like with the complementation rule, if I know the area under the whole curve is what? 1, that's right. So if I'm able to look up the area to the left of 0.76, this side, I can find the area to the right simply by subtracting from 1. So I'm going to look up 0.76 on my table. 0.7764. Okay.
Subtracted from 1 is 2, 2, 3.
So 0.2236 when I subtract it from 1. Thank you. Here's a little pro tip in my goldenrod yellow ribbon there. Find the area to the left and then subtract from 1 whenever you're finding the area to the right of a specified z-score.
Wait, so I didn't even have to do the subtraction?
You did. 1 minus 0.7764 is equal to, I looked up 0.76 on the z-score table.
And it gave me
And
2236.
positive 0.76, positive 0.76 gives you 0.7764.
Is that the actual? I'm confused.
That-
We didn't even have to do the minus 0.77. We were just gonna get, if we just had to look it up, probably have to, I don't know.
So the area to the left of 0.76 is 0.7764.
Yeah,
But I'm looking for the area to the right.
which is 2, 2, 3.
Mm-hmm.
Okay,
I had to subtract from 1 to get that.
okay.
So we'll do that again a couple times. So with a z-score of 0.03, so I go to 0.0, go over to the 3, I get 0.5120. That's the area to the left. So I'm going to do 1 minus 0.5120, and I get 0.488. And then for B, if z equals 1.27, 1.2, is 0.8980. 1 minus 0.8980 is 0.102. I'm going to let you try C and D on your own. if we look up z equals 1.33, we get 0.9082. 1 minus 0.9082 is going to be equal to, good.
What's the point of doing that?
So these areas are always telling us the area to the left of a z-score. So if it asks me for area to the right of, so if it's saying, hey, what is the probability that someone has an IQ of greater than 100, that'd be to the right of 100, we would just have to find the z-score and do 1 minus that. It's always, all of these areas are to the left of any given z-score. So D is 1 minus 0.1867, which is 0.8133. So for negative 0.89, if we go to the negative side, negative 0.89.
Oh, negative.
Oh, okay. That'll do it. And then this third section is between. So find the area between two specified z-scores. What we need to do here is, if you think about the area to the left of negative 1.82, I'm going to use a little color coding here. If I look that up, 1.82 is 0.9656. So this whole thing would be 0.9656. So I don't want the whole thing. I really want just the part that's in this region here. I could subtract off the area to the left of negative 0.68 and have the region I want. So negative 0.68, negative 0.68 is 0.2483. So this area right here is 0.2483. So I'm going to subtract the 0.9656 minus the 0.2483. That way I get just this region in between the two z-scores. That's going to give me 0.7173. So the pro tip here just says find the area to the left of each z-score, then subtract the larger minus the smaller. So we'll take a look at another example. Let's say we're talking about the area between negative 1.25 and positive 1.25. So for A, I could look up negative 1.25. Be ready, I'm going to call on you at random. Find the area to the left of negative 1.25. Mendez? The area to the left of negative 1.25. Yep, 0.1056. I'm putting that on the bottom of my subtraction. That's the smaller of the two numbers. So I have to subtract the bigger minus the smaller. So what then is the area to the left of 1.25? 0.8944. So we subtract those two and we get what? 0.788. Nice job. area between, you're just finding both and subtracting. Do you think you got the idea, or you want me to do one more example? One more, we got it. B. So if I have these two values, z equals negative 2.09 and z equals 0. If you're picturing it, you're thinking, okay, here's 0, here's negative 2.09, somewhere down here. And I want the area between these two. Well, what's the area to the left of 0? Every time? 0.5. It's also in the chart. If you forgot that, you could look it up. 0, 0.5. So we're going to do 0.5. And then we need to look up the other number, negative 2.09. Good. 0.0183 minus 0.0183. Subtract the 2, and we get 0.4817. So these are our 3 different scenarios that we will find when finding area under the normal curve. We're going to find some combinations of the 3, but if you're good on these 3, you should be able to find any combination that we're looking for. The summary of it all is right here. I'm going to take a break in the notes. We'll pick it back up in just a minute.